Alright, this is my independent project. I focused on doing node-based pathfinding. And what that means is that we're going to have this AI guy here follow me around. But there's going to be certain times where he can't reach me, namely when he's on the other side of an object. He's going to have to find a way around that object. And this is where the node-based pathfinding comes in. As you can see, I have this very basic level set up here. And these pink boxes here on the corners of these walls are all nodes. The walls themselves are just simple collisions, so they will block raycasts and things of that nature. I have a player controller, a very simple one, with just some simple movement and stuff, with a few simple controls. I can control this AI character with my left click, so I can tell him to move or not. And when he does move, he simply just follows me around, just like so. This right here is the first part of the script. It's very basic. He just follows you if he has a direct line of contact. It's when there's obstacles in the way that things become more complicated, such as these walls here. So if I go over to the other side of this wall here by jumping over it real quick, he's not going to be able to go directly towards me, and this is where the script's going to come into play. He's going to follow these nodes on their sides in order to get to me, depending upon which is the shortest run to me. So I had to move forward, and here he's going over this node there to follow after me. And the thing is, this script, I have it updating right now on the update tick, so it updates it in real time. So I can move around, and he's just going to actively pursue the fastest path to getting towards me. The other ability that the player controller has is the right click option. And what the right click will do is it controls this gray wall over here. So I can move this gray wall and put it wherever I want, like so. This shows that the pathfinding script is being updated in real time, and he's going around a different location to get around that obstacle. But if I put in a tricky path like this one here, I'm completely boxed in, there's no way to get to me, and this is where he stops moving altogether, because he cannot reach me. Likewise, if he moves into here, and then we put the wall behind him, and I go outside, the same thing's going to happen. He's not going to have any access to any nodes to be able to reach me. So he can't move, so he just stays there. Now I'm going to flip over to the code side of things so we can see what's going on over there. I got this 3 C# classes for this. The first one is the node class. This is basically more or less exactly according to the tutorial that I found. It has a class of a point, and inside point it has data members that control everything the point needs to know. It has a set of mutators and accessors for all the needs you'll need for it. The more important part is this path function here. This path function, when called, you have to give it a starting location and a target location. The start is obviously going to be where the AI character currently is, and the target is going to be the player. And it returns a list of vector locations. So at every index of this list, in order, it's going to give us a location of the different nodes in the path in order to reach the player. It starts off with a pretty basic thing where it basically says if it can go directly to the target, then it's just going to put those 2 things in the path and send it back to you. If that is not the case, however, then things get a little more complicated. We have to grab nodes, like all of the nodes in the map that have that node tag, and we get them into a nice big old list, and then we start connecting them together in order to find which nodes can go to which other nodes. So now we have a list of all the different nodes that can go to any other node. Then we have to go through and find, of those possible connections, what is their distance. So we can use that to find the lowest distance. And once we get that all set up, then we can find a path or a list of points that has the fastest route to the player. And with that, we can return that. But if we can't find a path to the player, if there is no way to reach him along any of the nodes or their connections, then we're just going to return null down here. Up next is the actor script. This is what is put with the player-controlled character in addition to the normal controls. But this part is specifically the stuff relating to the node-based behavior. The update goes through and checks to see if the AI is moving or in a state of moving. And it also has a minor check to see or make sure that the player is not jumping currently. And this just sets up a target that's the player's position and sets the target of the AI to that. And this set target is going to build that path, or use the path function, and find a path to access or get to the player. Then we have a few other options for the controls. For the left mouse, we have two different if statements for that. We have one if the AI is currently idle, and we have one if he's moving. And all it really does is it basically swaps them. So if he's idle and we left click, we tell him to move. We tell him to move by setting his target to a valid target. This is going to also change his state to moving. If he is already moving, we just change his state to idle, and then he will no longer move. Lastly, we have the right click option, and this is controls getting the information from where the user clicked on the screen and converts that into some data that we can use to affect the transform position of the wall. And lastly, we just have some code to detect whether or not the keys are up and buffers them. The last class is the AI's class, and this class controls the AI and where he goes and all that. The most important part of it is the update here, which if he's currently idling, we just return out the update. We don't do a darn thing. But if he's moving and our node's index is less than the path's count, basically if we're not at the last part of the path, the last location of the path, we'll go through and we'll decide what we need to do based upon that. I have an if statement here that's using a raycast that checks between the target's position and the AI's position, but this was more of an early thing for when I had different functionality implemented. And the bigger part about it is that it checks the target distance to make sure that the target is farther away than our follow distance variable, which controls the radius in which is acceptable to be on the node. This is so that, like, if this wasn't here, it could move beyond the node's location and think that it still is a certain distance away from the location, so it will turn around and then try to move again. But because of its distance which it moves per tick, it would never land on the node. So this is just kind of like some error checking for that. And when all that's correct, we just call the move toward target function, which is down below. And of note is that we return out of the function immediately. It works kind of like an else if of sorts. Otherwise, if we are within the follow distance, this means that we have reached one of our targets. In this case, we're going to set our state to idle, we're going to increase or increment our index, and we're going to set our new target to that next part. And that's not really much of the magic yet. The magic down and below is in the set target function and the move toward target function. Above that, we just have the mutator and accessor for the states. And the set target function uses that in order to set the state when we get a target. It basically just takes in the target variable passed to it, and it creates it with the path function. The path function will return a list of vectors again, which is all the locations it needs to get towards the target. And it sets it along the first one. Of note is that at index 0 is the AI's own location, so obviously we don't need to go to that path node. Lastly, we have the move toward target function. This one's pretty simple. All it really does is it makes a position for the AI to move to and sets it to that, and it sets a rotation for the AI and sets it to that as well. And that is all for this one. Thank you for your time, and have a good day.